In this video, I'm going to be showing you one of the best SAT math tricks out there. It's one that helped me get an 800 on the SAT math section when I was in high school. It's one that you can use on other math tests in general, including the ACT. And it's honestly really not that hard to learn. So let's jump into it. So I'm going to teach you how to use this trick on this first problem. This problem actually comes from the College Board website, the maker of the SAT. So they put these questions out there to try to be as similar to the actual SAT as possible. So this question honestly isn't that hard to solve in general if you're just using basic arithmetic, but I do want to kind of just give an intro to this SAT trick with an easier question. So it says, which of the following is equivalent to the sum of these two expressions? Now, obviously, like I just said, we can pretty easily just add the a squared and the a and the -1 and the 1. Sum just means addition, of course. The ones cancel, and we're going to get answer choice A. But another way we can solve this is by making up a number for our variable. So I'm going to say A equals 4. And now they say which of the following is equivalent to the sum of the expressions a squared minus 1. So a squared minus 1 is going to be 15, and a plus 1 is going to be 5. Again, taking into account that a is just 4. So which of the following is equivalent to the sum of those? Well, the sum would just be 20. And we can plug that a back into the answer choices and see which one gives us 20. So in the first answer choice, we already know that's the answer. A squared, which is 16, plus a, which is 4, that does give us 20. So I'll put a check mark next to a. A cubed, 4 times 4 times 4 is 64 minus 1, that's 63. No good there. Answer choice C. Well, let's do order of operations. We'll square the a first. 16 times 2 is 32. That's no good. And just a to the third, a cubed, is 64. So that's no good. So basically, we just make up a number for our variable and plug it into the question and plug it into the answer choices. So one of the most important things to know about this strategy is when to use it, because you can't always use it. So first off, I recommend using it when we see variables in the question and also variables in the answer choices. I kind of mutilated them here, but yeah, we see a bunch of A's in the question and the answer choices. Now, that's not to say you always want to use this strategy. I'll give you a couple examples where you do not want to use it in this scenario. So in this question, there are just way too many variables to be plugging in. You'll waste so much time. This came from a non-calculator section, so it's impossible to use this strategy with this question. Yes, so for here, I recommend just distributing the negative sign and combining like terms. I'm not going to go through it. That's not the point of this video. The point of this video is just to show you my favorite SAT strategy. So I'll get that off the screen. Here's another one. I don't recommend using it. It could work. You could make up a number for x. You could plug it into these two guys. And it says which of the following is the sum. So you'd add them up and see which one gave you the same number as when you plug that number you made up for x into these. I think this problem's too easy to use this strategy. I wouldn't rely on the strategy completely. It's much easier to just add coefficients here. 3 plus 5 is 8, so we get 8x squared. -5 plus -2 is -7, so we get -7x. And then 2 plus -6 is -4. So very, very, very easily, I get to my answer, which is A. That's just basic combining like terms. That's not a strategy you should avoid on the SAT. You should know how to combine like terms without using this special SAT strategy. So here is a question, and I'm going to have a bunch of questions we're going to go through where we are going to use this strategy. So if A over B equals 2, what is the value of 4B over A? The difference between this question and the first one I went over is, in this question, they actually give us a constraint on what our variables can be. Our variables A and B must divide to equal 2. So I can't just say A is 1 and B is 7. That doesn't make sense here. They need to make sense with the problem when you make them up. So I'm going to say that A equals 4 and B equals 2, because A over B will then give me 2, like the question says. So it says, what is the value of 4b over a? 4 times 2, 4b over a. So 8 over 4 is just 2. So very simply, my answer is C, 2. By making up numbers for my variables and plugging it into the answers. Or basically here, plugging it into the original question. Yeah, we didn't have variables in the question here, but we kind of did because the question is, what is the value of 4b over a? So once we made up our variables, we plugged it into here instead. So you can kind of see the intricacies of this strategy. Sometimes you're plugging them into the answer choices, but here, not so much because the answer choices aren't variables. Alrighty. Another question. A little more difficult, but this is one of the straight up variables in the question, variables in the answer choices. So I'm going to make up numbers for my variables. I'm going to say x equals 3, and since I see a radical for a, I'm going to make up something for a that's going to be easy to square root. So I can just say a equals 9. Okay. So, notice how I haven't made anything up for y. I did that on purpose. I'm going to figure out what y is, so I don't need to make it up. So I'm going to plug x and a into here and solve for y. X squared, well, 3 squared is 9, minus a, which is also 9, so y is 0 here. Okie dokie. So I have my 3 variables, and I'm going to plug them into the answer choices and see which one gives me y equals 0 when I plug in x and a. Just a little tip. I deliberately made up the variables on the more complicated side of the equation. That way, when I plug them in, I can get the less complicated side of the equation. If I make up a number for y, I'm going to have to rearrange and stuff and solve for another variable. I don't recommend it. I recommend when you make up variables, you make the variables up that are on the more complicated side so that it's easy to just get the simple side. So, like I said, x is 3, a is 9, and y is 0. We'll plug them into the answer choices. So for the first one, x plus a. So 3 plus 9 is 12. X minus a, 3 minus 9 is negative 6. Multiply those, there's no chance you're getting 0. A's out. X plus the square root of a. See, this is why I made a 9, so it would square root nicely. So 3 plus the square root of 9. 3 plus 3 is 6. Now x minus the square root of a. So x minus 3, 3 minus 3 is 0. And 6 times 0 is 0. So B is the answer here. However, it is a good idea to check the other two answer choices just to make sure another answer doesn't give you 0. So x plus a over 2, that's 3 plus 4.5, so 7.5. X minus a over 3, so 3 minus 4.5, whatever. No 0 there, so when you multiply, you're not going to get 0. And then x plus a squared, 12 squared, 144, no good. So we know B is the only answer that works. That must mean that B is our answer. But yeah, just make sure you try all of the answer choices because it is possible that you get multiple answers to work. And that's one of the reasons I recommend making up numbers that aren't like 1 or 0. If you make up 1s and 0s, a lot of the time you will get an answer choice that works. That's not the correct answer. So make up a little more difficult answers or a little more difficult variables so that you're not going to end up having multiple answers that work. Next question. So this one's a little more complicated, and we're going to see a bunch of different ways we can use this strategy and a bunch of intricacies and a bunch of things that you do actually need to know on the SAT other than just this strategy. The surface area of a cube is 6 times the quantity a over 4 squared, where a is a positive constant. What's the perimeter of one face of the cube? So let's make up a number for a. And this is where we want to get strategic. So I'm not going to make up a number like 1 for a. Why not? Because when I plug it back into here, I'm going to get a fraction, which is no fun. So why not just say a is 4? That way when I plug in 4, the fraction cancels. So a really, really, really good idea is to make up numbers strategically. That way you can save yourself some work in the end. So the surface area of a cube is now 6 times 1 squared. So the surface area equals 6 times 4 over 4 squared, which is just 1 squared. So the surface area of a cube is 6. And if you recall, where's my Rubik's Cube? 6 sides of a cube. So that means that each side will have an area of just 1, because if I have 6 sides and the total area is 6, then the area of each side is 1. So I'm going to write area of one side equals 1. So that means I have a square, right? The sides of each side of the cube. It's a square. So if the area of this side is just 1, or 1 square unit, that means that the length and width are both 1, because length times width of a cube gives you the area of one side. So that means that the perimeter of this side, like the question asks for, is 1 plus 1 plus 1 plus 1, which is 4. So the perimeter equals 4. And now they want which of the following gives the perimeter in terms of A. So A over 4. That means that the perimeter would be 1, because 4 over 4 is 1. Nope, we said the perimeter is 4. A, yes, A is 4. That was the perimeter, so B is the answer. C and D, 16 and 24, no, the perimeter is 4. So we do need to know about surface area. We need to know about cubes and stuff. So make sure that we're still studying for the SAT. We're not going to use this strategy to just take over our SAT. There's still a ton else we need to know to get that 800 on the math section. Next question. Looks like we have about 5 more. So in the equation above, if A is negative, okay, A equals negative 2. And B is positive, B equals 7. Which of the following must be true? Notice how, again, I made up the variables on the more complicated side. That way, I can get the less complicated variable. So A is negative 2, B is 7, so negative 2 minus 7 over A. I'm just filling in the equation to get C. So negative 2 minus 7 is negative 9 over negative 2. So C is 9 over 2. So which of the following must be true about C? Is C greater than 1? Yeah, 9 over 2 is 4.5, excuse me, because 2 goes into 9 4 times, and a half. So yes, A is correct. Now let's check B, C, and D. C was obviously not equal to 1 or negative 1, and C was not less than negative 1. So this was a pretty good question and a pretty quick one to use the strategy of making up numbers for our variables. Which of the following is an equivalent form of this? Now, if this were a calculator problem, I recommend just saying x equals some number. Let's say 1.3. Notice how I made it something that's a little more intricate. That way I know that multiple answer choices won't work. So what I would do here is I would plug in 1.3 into my calculator, and I would, type this in. I'm not going to do it because it does take a little while. So I'd plug in 1.5 times 1.3 minus 2.4 squared and so forth, and I'd get my number. And let's say that number was 7. And then I'd start plugging that same x, 1.3, into my answer choices, into where I see an x, and see which answer choice gives me 7. I don't remember off the top of my head which answer choice was correct, but that's the gist. This is an additional problem you can check, and I'll put the answer down below. Here we go. Here's another great one. If a squared plus b squared equals z, so which two variables am I going to make up? A and b, of course, because they're on the more complicated side of the equation. They're also on the more complicated side here. And by complicated, I just mean like more going on. This side doesn't have much going on. It's just a z. This side doesn't have much going on. It's just a y. So yeah, I'm making up a and b. Let's say 2 and 3. So a squared plus b squared. 2 squared plus 3 squared. I jumped the gun a little bit. So 4 plus 9 equals z. So z is 13. And then for y, a times b is y. So y is just 6. 2 times 3. here are the variables I made up. Z is 13, Y is 6, and then A and B are 2 and 3, of course. Which of the following is equivalent to 4Z plus 8Y? Well, 4 times Z, 4 times 13 is 52, plus 8 times Y, so 48, 8 times 6. So which of the following is equivalent to 100? And notice how all of these answer choices are squared. So we're probably going to get a 10 squared. Let's see which one works. A plus 2B. 2 plus 2 times 3. So 2 plus 6 is 8. 8 squared is 64. That doesn't work. 2A plus 2B. So 2A is 4. 2B is 6. So yeah, that gives me 10. And 10 squared is 100. So B is the answer. You can try C and D, but of course those are going to be too large. 4 times A is 8. 4 times B is 12. So 8 plus 12 squared, that's 400. 20 squared is 400. That doesn't work. And of course, if C is too large, D is too large. So that's our answer, B. Okay. This question, again, a little different. In the xy plane, if 0, 0 is a solution, don't forget, that just means that we can plug 0 in for x and 0 in for y. So our equations, when we do that, instead of y is less than negative x plus a, we really get 0 is less than 0 plus a, which just means a is greater than 0. And then in the second one, if y is greater than x plus b, so that just means 0 is greater than 0 plus b. Rearrange it a little bit to say b is less than 0. You can jump the gun a little bit and say if a is greater than 0, that means a is positive, b is negative, so the answer is a. Or you can make up a number for a and make up a number for b. If a is greater than 0, we could say a equals 7. And if b is less than 0, we can say b equals negative 2. And then we'll check the answer choices. B is, of course, not greater than a. That one's out. Is the absolute value of a greater than b? Actually, it is. So we'll keep that one for now. And then a does not equal negative b. So we'll get rid of that one. And now we'll make up new numbers for a and b. That's the beauty of this strategy. Once we eliminate answer choices, we can go back and make up new numbers for a and b and see if we can kind of break one of the rules. Is it possible to break this rule? Is it possible to break this rule? And the answer is it's actually possible to break the rule for C. Does the absolute value of A need to be greater than the absolute value of B? No. We could have said A is 1 and B is negative 4. So that means the absolute value of A is 1, the absolute value of B is 4, and 1 is not greater than 4. We will get rid of answer choice C. Last problem, if x is greater than 3, which of the following is equivalent to this? So I'm going to say x equals 4 if x is greater than 3. So I will plug that into the question. And this is actually kind of difficult. 1 over 4 plus 2 plus 1 over 4 plus 3. So 1 over 6 plus 1 over 7. Get a common denominator. You can just multiply the two numbers. 42. So what did I multiply 6 by to get to 42? 7. What did I multiply 7 by to get to 42? 6. So 1 over 7 over 42 plus 6 over 42 is just 1 over 13 over 42. Couple ways to get rid of the fraction within the fraction. I can just multiply the top and bottom. So multiply this by 42, multiply this by 42, and I just get 42 over 13. Another way I see it done is instead of the fraction 1 over 13 over 42, you can rewrite it like 1 divided by 13 over 42, and then you just keep change flip. So keep the 1, change the division to multiplication, and flip the fraction. So 1 times 42 over 13. Now comes the fun part. Plug in x into the answer choices. So if I plug in x into C and D, there's no way I'm getting a fraction. So I don't even need to try those. My answer should be 42 over 13. C and D aren't doing that. And now I can try A and B. So if I plug in A, 2x is 8 plus 5 is 13. I get a 13 on top. And on the bottom, x squared, which is 16, plus 5 times 4, which is 20, plus 6 gets me 42. Pretty close, just flipped. So the answer must be B, which is the reciprocal. The top is going to get me 42 this time, and the bottom is going to get me 13. So answer choice A is incorrect, and it's B, the answer. So hopefully you can take away a few things from this video. Hopefully you can apply this SAT trick in your studies. I don't recommend using it for the first time on the actual SAT. Definitely practice and see if you can get the correct answers with this strategy.
Brad does math.